Hello, today we are going to go through part B questions, the analyzing acid questions you had to do for last night. And then we are going to go over the next two Petri dishes where we classify bases. So you had to complete these analysis questions from yesterday. The first, and you had to use your textbook. The first acid we looked at was a weak acid. It had low ionization, only 20%. The next Petri dish we looked at was a strong acid. It had 90% ionization, very few acid molecules in solution, lots of ions in solution. The next Petri dish, number 3, was a strong acid. And it's diprotic because it has two acidic hydrogens, and it had 90% ionization. And then the fourth model we looked at yesterday is weak. It only has 10% ionization. And so we should be able to look at what we just did in number 1 and 2 to look at the relationship between the percent ionization and a strong acid. So our strong acids here have percent ionization of 90% or greater. And then we want to look at the table. What is the relationship between the percent ionization and a weak acid? So for these two weak acids, they both have the percent ionization is 20% or lower. And so yesterday we went through this packet, these 4 Petri dishes, these 4 models. I pointed out the arrows, whether they were double arrows showing us it's reversible, what we learned back in chapter 17 and 18, or if they were arrows that went in one direction. And so you can look at the arrows to determine if it's weak or strong. And when you write these dissociation equations, then you should be able to identify if it's weak or if it's strong. So weak acids have a double arrow. And so that double arrow means that the reaction is reversible. And then acids that have an arrow in one direction are strong. And that means that the reaction only goes forward. And so I'm going to list the six strong acids. You should know these acids for this class. And actually, I'll put these were also assigned earlier in the year. So these are the strong acids you should know. Anything else is weak. And so what we're going to do now is look at bases. So we're going to move on to classifying bases. I have two Petri dishes that we're going to look at to classify bases. For this first base that we're going to look at in Petri dish number 7, potassium is a group 1 metal, and then we have OH. So this is a group 1 metal hydroxide. And so for these two models we're going to look at today, the clear beads, the clear decorative beads are the hydroxide ions. And for this first model, Petri dish 7, the black bead is the cation. So we're going to look at this for just a minute. And so if you notice, none of them are connected in this example. And so the clear bead here represents hydroxide, and in this example, the black bead represents potassium. And so the dissociation for this base, potassium hydroxide, pointing out that the arrow here is going in one direction, it will form potassium cations and hydroxide anions. And so if we go back to our model, none of these are connected. These are all ions in solution. So we have no whole base formula units. Whoops, that should not be. And we have 100% that are broken into ions. There were 10 black beads and there are 10 hydroxide beads. It means 100% ionization for this potassium hydroxide base. So now for Petri dish 8, we're going to look at ammonium hydroxide. You can think back to your definitions of bases. Both of these examples we're going through will increase the concentration of hydroxide ions in solution. And so these are both Arrhenius bases because they increase concentration of hydroxide ions. I'm going to, again, clear is the hydroxide ions, the purple is the cations. And so I want you to look at this and I want you to complete the questions for Petri dish number 8. Think about it write down your answers, pair up, share your answers, just pair up with someone next to you. Don't get out of your seats. Please pause the video and work through these, and in about 4 minutes, we'll go over it. Okay, so looking back at this video, the Petri dish, coming back to the video, the purple is the ammonium cations, and the clear ones are the hydroxide anions. So the purple ones represent our cation, and the clear ones represent our anion. And so if we write the dissociation equation for this, you get ammonium cations and hydroxide anions. So we're going to go back and look at our model and look at how many were together. And so I have 1, 2, 3, 4, 5, 6, 7, 8, 9 that are together. These two are apart. You have a cation and then you have your anion. So 9 whole base formula units. So 90% of them, because there's 10 total, 90% are whole bases. 1 is broken into ions. We had 1 ammonium cation and 1 hydroxide anion. And so 10% were ions. And I do want to point out here, this was a double arrow for this dissociation equation, which should mean something to you from our discussion yesterday, and it should mean something to you from chapter 17 and 18. That is reversible. What you're going to do now, we're going to do these analysis questions now in class. You'll need to open up your book on page 457, figure 1.11, complete the type of base column, use what we just did to complete the percent ionization, answer the questions. Please pause the video for about 8 to 10 minutes, and then I will go over it today so that you have the answers. So go ahead, pause the video, work with someone next to you to complete questions 1 through 5. So the type of base for potassium hydroxide is it's a strong base, and ammonium hydroxide is a weak base. Looking at our data from our handout, the potassium hydroxide was 100% ionization. The ammonium hydroxide was 10% ionization. And so for a strong base, the percent ionization for a strong base so the percent ionization for a strong base is 100%. You need to memorize that group 1 and group 2 metal hydroxides are strong bases. Anything else besides a group 1 or group 2 metal hydroxide is considered weak. And so weak for the weak bases The percent ionization for a weak base is 10% or less. And you should know from before, you should know one of the weak bases we use a lot in class. You should know the formula and the name for ammonia. And so going back to the activity, looking at the models, I pointed out the arrows to you. If it's a double arrow, it means it's reversible, and weak bases will have a double arrow. If it has an arrow just in one direction, it's a strong base. And it means the reaction goes in the forward direction. It's not reversible. So in this, my acid can beat up your acid, and so can my base. We've classified acids, we've classified bases. You should be able to write dissociation equations. You should know the difference between a strong acid and a strong base. You should be able to draw a model of a strong acid or strong base, or a weak acid or a weak base. You should be able, if I gave you a model of an acid, you should be able to tell me if it's strong or weak. Those are the things you should know from this activity. These are your notes. You can also read in your book about strong and weak acids as well. The PowerPoint that you're using in class with the video links is in Mrs. Arnold's chapter 14-15 notes folder in Schoology. I also have linked my OneNote in that folder so that you can use that as a reference as well. If you have questions, please go to room 335 to see me, Mrs. Chapman, or send me a message in Schoology with any questions or concerns. Have a great day.